Okay, for this video, I'm going to be talking about PIDs, specifically 3D printer, how they use PIDs versus cruise controls, how they use PIDs. So, when we were talking about what the PID is changing with a 3D printer versus a cruise control, with a 3D printer, the PID loop is used to help control the temperature of either the extruder nozzle or the print bed. So in the olden days, most temperature controls were done in an they call it a bang bang manner, which is like it's either on or off. And so, like if you think of old coil stovetop, the temperature, it will turn on the coils and those will heat up, and then once it gets past the temperature that it wants to be at, they just turn off and it cools back down until it's below the temperature, then it turns back on and heats back up. But with 3D printers, if they were to do that, that would be bad because then it would mess with the consistency of the plastic that you're putting out, and so that plastic would be not as uniform. And so with a PID loop and adaptive heating methods, they can get it to that temperature and keep it more consistently at the temperature that you want instead of it fluctuating up and down. With a cruise control, the thing that you are controlling is the speed of the car driving down the road. The PID loop is controlling like how fast you're going down the road, and if you experience any hills or anything like that, the PID loop is used to counteract those hills and make sure the car maintains the speed that you want, even with hills and so on and so forth. So first we're going to talk about the P, which is the proportional. So with a 3D printer, this adjusts the temperature based on the ratio of the actual temperature to the requested temperature. So it looks at the actual temperature that it is at and the requested temperature that you want to be at, and it will either make it give more heat or less heat based off those two temperatures. With a cruise control, this is adjusting the throttle of the car based on the difference between the desired speed and the actual speed. So it's kind of the same thing. This one's just looking at the speed that you want to be going and the speed that you're currently going, and adjust the throttle based off of that. So both of them are looking at where you want to be and where you are right now and getting a value and putting that in. Just one of them is temperature, of course, and one of them is the speed that you're going. So the next one is the integral. So with a 3D printer, this is based on the difference between the actual temperature and the expected temperature in the past. So it's a compounding effect. So it looks at where you are now and what temperature you expect to be at, and then over the time that you are monitoring it, or like the time that it does each loop, and then it changes the temperature based on that. So it's kind of a compounding effect. With cruise control, it's based on the time integrity of the vehicle speed error. So it's how far the car actually traveled compared to how far it was supposed to travel. So once again, it's that compounding effect. So both of these ones, they, at the beginning, when the PID loop is started, these ones will have less of effect, but over time, these are what will have more of effect on the PID loop and the speed or temperature of the car as it is going along. So the final thing is the derivative. So with a 3D printer, this is based on the speed at which the temperature changes from being above or below the target of the temperature. So it's looking at the speed that you're changing, and it changes based on that to make sure you don't overshoot the temperature too much or like shoot below it if you're above it and you're coming back down. It helps it to dampen that temperature change when you're getting near the target. And with the cruise control, it's based on the acceleration of the car. So it takes samples and it's based on the rate of change between the samples. So this can be like as you're getting up to speed, it looks at the acceleration that the car is doing, and it will slow that acceleration as it gets close to the speed that it wants to be at. Or it can look like if you start to go up a hill and your acceleration starts to drop, it will look at that and it will change the throttle to give you more acceleration to get back to where you need to be if that acceleration does drop. So it's kind of like the acceleration of the temperature or the speed of the car that like change to help dampen it, to help it get to its target without overshooting or undershooting it, kind of thing. And then here are my references where I got all this wonderful information and learn more about all this stuff. Thank you.